So this is chapter 4. We are doing inverse variations. Is going to be the thing we are talking about. Inverse variations is a relationship between two variables such that one variable increases, the other one decreases proportionately. I'll read that again. That is something you need to know. An inverse variation is a relationship between two variables such that as one variable increases, the other one decreases proportionally. That doesn't mean that x has to increase every time and y has to decrease. It could be either way. They have to do it proportionately. So to give you an example of what something looks like when it varies inversely, this is an example of a inverse variation. If a real easy way to check, or actually we'll do the easy way at the end. If I look at this right here is multiplying by 2. If I look at this is dividing by 2, right? So as this increases, proportionately this decreases. As this times by 3, this divides by 3. From here to here I times by 4. From here to here I divided by 4. So as this is going up, multiplying a certain way, this is dividing. Another easy way to see if they do that a quicker way is just to take the x and the y and multiply them together. And if it is a inverse variation, it will give you the same number every time. So like when I multiply this times this, I get 12, 12, 12, 12, and 12. So you can tell that this, yes, is a inverse variation. So the question is this a inverse variation? Well, as soon as I try to do x times y, I realize that this is 20. I realize this is 34. As soon as one of them doesn't match up, and it is not a inverse variation. In fact, it's going to bring me to my next point of what we should be able to do in algebra 2 is this is actually a linear. This would be a linear function. The way I know that is as this increases by 1, this decreases by 3. Up 1, down 3. Up 1, decreased by 3. It's staying the same. Up 1, down 3. So it's like me going to the right, because that's x is right and left. To the right 1, down 3. To the right 1, down 3. To the right 1, down 3. Also known as a slope, which is going to create a linear. So this is old school linear. In algebra 2, we have been studying things. You have been studying linear. And you should know what it looks like on a graph. You should also know what it looks like as a function, like y equals mx plus b is a way. As soon as you see this, you know, maybe a y equals 5x minus 2, you should know that that's linear. If you see ax plus by equals c, known as standard form, you should know that that is linear. The last form is point slope, which would be y minus y equals m times x minus x. That is point slope form. All three of these forms you should know, and they were taught to you, and they make a linear. They're going to make a straight line. You studied those. You went through each one of those forms. You should know how to manipulate them and handle them. We then went on to quadratics. And we know that quadratics are when x is to the second power. So it was something like in standard form, ax squared plus bx plus c equals y. This was standard form. We also had x minus h squared plus k equal to y. This was called vertex form. And finally, we had x minus, I'll just do intercept 1, x minus, and it could be plus or minus, intercept 2, and that equaled y. This was called factored form, something like this. I think they used a different variable, but these were numbers. This is when I had x minus 2, x plus 3 equals y. Since there are two bubbles, I know that this is quadratic because that would get me to x squared. And this is factored form, which gets me the x-intercepts really easily. And I can graph that by using those intercepts. That's something that we studied at the beginning of the year. We then started talking about x to the third, x to the fourth, x to the fifth. This is cubic, this is quartic, this is quintic. And we talked about how to factor. You can put them in factored form, really. And the only two forms we talked about are factored and standard form. Whatever, it's ax to the, let's say, fourth, plus bx to the third, plus cx to the second, plus dx, plus e equals y, whatever. Doesn't matter. It always just has to go from 3 to 1, 0 down. That's going to be standard form. Factored form would be bubbles. If I was in the third, then I'd have 3 bubbles. If I was in the fourth power, to have another fourth bubble. If I was in the fifth, I could probably have 5. Maybe not. Maybe have one of these squared, but this is 1, 2, 3, 4, 5. This one would count as 2 bubbles, so I know I'd be in the x to the fifth, a quintic. So this is what we've studied in the past. Now what we're studying is a new one. We are studying one that is called a inverse variation. When I say something varies inversely, or you hear y is an inverse variation, or any kind of verbiage like that, your equation that you are going to use is going to be y equals k over x. This is, as soon as you hear inverse variation, this is going to kick you to this type of equation. If you hear linear, we said it's going to kick you to maybe this one, maybe this one, right? Like we're starting to, this is like math is becoming a science. And when you hear something, things should start to, they move and behave differently. And when you hear inverse variation, this is key. That should come to your mind. And what happens is this is going to be just a constant, some number that's going to stay the same. So if I asked you to do find the equation when x equals 10 and y equals 3, when x equals 10, I guess I should say then y equals 3 because these are in order pair. Find the equation. So the first thing they say is, hey, x and y inverse vary. They vary inversely, which keys me to this equation. So that's going to be the first thing I say in the maybe the word problem. Then they're going to say when x is 10, then y is 3. I want you to give me the equation of that inverse variation. And so all you're going to do is you're going to go, okay, that's 3 over here equals k over 10. And what I'm trying to do is in order for me to have this equation, all I need is the k. X and y are going to be the variables. So when they say find the equation, the only thing I need to do is find the k. The division, a fraction bar is division. So how do I undo that? I times by 10. I times by 10. And I get 30 equals k. So to find the equation, the answer to that question is y equals 30 over x. That would be the answer to find the equation. The next part they might say is then find y if x equals -6. And all you're going to do is you're going to say y equals 30 over -6. Y equals 30 divided by -6 is -5. And that would be your answer to your second question. So try this one. In an inverse variation. As soon as I see that, what does that clue me to? Someone help me out.
Y equals k over x.
Y equals k over x is exactly what I should see. That's what I should hear. x equals 6 when y equals 1/2. Write the equation, then find y when x equals 1/2. No, I'm sorry, x equals 15. So go ahead and try that on your own for just a minute. All right, Taylor.
Yes.
What's the first thing, as soon as I say that in an inverse variation, what was the first thing we said we recognize? What does that mean to me?
I forgot.
Did you write it down? The equation?
No, I didn't. My computer's been really glitchy, so I'm sorry. My Wi-Fi's been bad.
Okay. Make sure you go back and watch this video then.
I will.
Tucker?
I don't know either.
Did you write down the equation of what
No.
we've been talking about today?
No.
Okay. So when I'm doing this, you guys should be taking some kind of notes. It's just like you're in class. You should be writing down things, not just watching. Nina?
Y equals k over x.
Thank you. Appreciate that very much. Y equals k over x. All right. Trey, what would I do next then, bud? Trey Hood. Trey. Noah?
I know.
I'll get you next, Annabelle. Noah?
Yes, sir. Which Noah? I was gonna say there's
You.
like 3.
You know Brown, buddy. What would I do
Well-
next?
Truthfully, I don't know.
Well, Noah, what's the thing I said I needed to find in order to have this equation?
Find the y. Oh, you already
No.
found one.
No? This is why this is frustrating. Legit, I just did the same exact thing right here. What did I say we need to find? I circled it. What's the only thing we need to have when we do this equation?
Okay.
Okay, but when they give me the equation, if you look at that, they don't give me k in this, do they?
No.
Okay, so I need to find the k. Well, what did they give me that I can use to help me find the k? If I read the question, what did they give me?
X.
And so what is my x in this question?
6.
And what is the y at that same time?
1/2.
Because what do I know about x and y? They can change. So if x isn't 6, then y isn't 1/2, right? When x is 6, then my y is 1/2. Those go together. They're like dating. If you see 6, you see 1/2. If you see a 5, you don't see 1/2. Okay, these guys go together. Okay, so the purpose of me doing this is I'm putting in the 1/2. I'm putting in the 6. What's the only variable left, Noah?
K.
And then I can work backwards to solve for it. How do I undo dividing by 6, Annabella?
Multiply.
If I multiply both sides by 6, fractions work we need to get better with. Top times top, bottom times bottom. You can also cross simplify. This can turn into a 3, this can turn into 1, and so this whole side turns into a 3 equals k. So my k is 3. So what's the equation? Y equals 3 over x. There is the answer to the first part of this question. The next one says, what is y when x is 15? So that means I'm actually going to take here, and now I'm changing the x. Now no longer is x 6, it's 15. And when I do that, my answer is 1/5. That's because 6 and 1/2 go together. They're called an ordered pair. And 15 and 1/15 or 1/5 go together. These guys are an ordered pair. These guys are an ordered pair. All from this same equation right here. If you put a 6 in, you're going to get out a 1/2. If you put a 15 into here, you're going to get a 1/5 out. Try again. The same exact question. Try that on your own, please. If anyone is missing any tests or any exams, they need to also tell me that too, please.
Mr. Martin,
Yes.
I'm still missing the 2 tests from last quarter.
Then you need to go on Performance Matters and take them.
All right.
And you also need to tell me that tomorrow that I need to check that, because I'm any of that kind of stuff that's late, man, that's on you to make sure that I put that in there. I've already put those tests in a long time ago.
All right, I got you.
Which one are you missing, Noah? No, are you missing both retests?
Yeah.
You're also missing the exam review.
I know I did that. I'm gonna look and see if I turned it in. I know I have it. I just caught up on my AP English grade. So I'm gonna do that. I'm gonna do the test like right now.
The 3.5 test is released.
Thank you.
I'm giving you the retest on the other one. So when I look for the grade tomorrow, you need to remind me that it's in the retest, please.
I will.
It's like I said, tomorrow when I get to class and we're talking, you need to be like, Mr. Martin, you need to grade those 2 tests or else it'll just be what it is.
All right.
Both your tests are released, bud. And then I need you here in class from now on, every day.
I will. I should be coming back to the building soon, so.
Okay. All right. I'm going to try again, Taylor. Taylor.
I didn't get the notes from the first part, so I'm on YouTube trying to do them right now. I'm trying to multitask. I'm sorry.
No, did you watch what I did? Because I literally did that question. Did you write that down, the last one? Because this is the same exact question that I did before.
No, I didn't because my Wi-Fi was bad, so I'm on YouTube trying to get caught up with the lesson while we're doing this at the same time.
Okay. I'd rather you watch me more than anything else.
Okay.
Because I'm doing the same exact questions. Janina, can you tell me the equation to this that I need to be thinking of?
Y equals K over X.
The way you are. Is that Bruno Mars back there? No? Okay, Janina. All right.
What?
It's a little Bruno Mars in the background.
That's my sister.
Blame it on the sister. We'll never know. All right, so it's y equals k over x is exactly what I should be thinking. Daniel, what would I do next, bud? Are you talking?
Can you hear me?
Yeah, now I can.
All right, so you replace the y with 5 over 6.
Perfect.
Replace the x with 2 over 3.
Perfect. Very good. Thank you so much. Tucker, what would I do next? Or Dominic? I haven't talked to you, Dominic.
Multiply both sides by 2 over 3.
Perfect. Because I'm undoing dividing by 2/3 and multiplying it. Perfect. Sierra, how do I multiply fractions? Sierra?
You just do them across, right?
Yep, so top times top, bottom times bottom. So this would turn, now you can cross simplify, which we'll talk. I like simplifying before I multiply. So meaning I would look at the 2. Does the 2 have anything in common with the 3 or the 6? And yes, it does. It has something in common with the 6. So I go 2 goes into once, 2 goes that 3 times. I like to simplify first. Then I look at the 5. Does the 5 have anything in common with 3? No. Does it have in common with this 3? No. So then this would end up being 1 times 5, which is 5, over 3 times 3, which is 9. You cannot simplify this 3 with this 3 because they are both located in the denominator. So K equals 5/9. So since K equals 5/9, the final answer for this would be Y equals 5/9. That's my K over X. Sierra, when I talk, make sure you go ahead and answer, or else I'm going to be removing you from class. Even if you don't know how to do it or whatever, if you can't have a mic, then you need to just text in the conversation or something. All right. Now, the other thing is, this might not be the answer. That's what I've been trying to tell you guys about. Math kind of sucks. Let's think how else they could rewrite this. What does this truly mean? Savannah. Savannah, can you help me out? Josh.
Yeah, can you hear me now?
Yep. Can you tell me what can you read this to me? What does this really say?
You have, does that say 3/9 or 5/9?
It's 5, sorry.
5/9 over X, so Y equals 5/9 over X.
What does over really mean though, Josh?
Over, it's just divided by.
So can I rewrite this as this? Is that the same thing, Josh?
Yeah.
It is 100% the same thing. Now, why would I write it like this? There is a rule. If you remember, Josh, how do you solve this question? Do you divide fractions?
You multiply I believe it's like cross or something. You multiply the 1 by the 3 and the 2 by the 1.
Okay, so what I teach my kids is what it's called keep, change, flip.
Yeah.
So what you do is you keep this front number, you change this to multiplication, and you flip this, which means reciprocal.
Yeah, that's
so we never ever divide fractions. We actually multiply them by its reciprocal, and then this would end up with 3/2 would be my answer. Does that make sense?
Yeah.
Okay, well, anything that I've learned in the past, I can apply here. Do you see how I'm dividing? And then can I make this a fraction? Sure.
X
So instead of doing it like that, I'm going to do 5/9 times 1 over X. So you might actually see the answer written as Y equals 5 over 9X. This has the same meaning as that.
All right.
Then they said, find Y when X equals 1/3. Austin, how do I solve that? How do I find Y when my X equals 1/3? Now that I have this equation, what am I supposed to do? What's the goal, Austin? Find what?
Find Y.
When?
X equals 1/3.
So instead of writing like this equation, I'm going to write everything the same, except what am I going to put in place for X?
1/3.
And then 9 times 1/3. We've just been going over this. We need to keep going over fraction work. What did I tell you can do? Cross simplify. 1, 3. This turns into 3 over 1 or 3. And I end up with Y equals 5 over 3. So Y is 5/3. That's the second part of this question. Does that kind of make sense? Questions on those two types of questions?
Is this all our homework's going to be on?
Nope, this is just the start.
Okay.
This is just the start. Now what we're going to do is kind of graph these suckers. And when we graph them, it's called a reciprocal function. But that's because it looks like this. we're going to start off with what we call the parent, which means it's the basic one. Everything else is going to be based off of this, but they're going to have the same shape and have the same kind of structure. So what's going to happen here is we're going to have these new words that are going to appear. These words are going to be, this word is going to be called an asymptote, and I'll show you where it happens, and we're going to talk about why it's going to happen. And this is where we're going to kind of finish our day up. We might actually get most of this lesson in, and then tomorrow, basically just have an extra day for any questions because of the weird bell schedule that it gave us today. They didn't make you guys a skinny. And it's easier with my onlines. I don't have to call you up, and it doesn't disrupt class as much for turning in assignments. So let's go ahead and try to graph this. First off, if I put a -3 in, that means that's my x. What's my output? Someone answer that, please.
Negative
Nina?
1.
Okay, Kelly?
Sorry, negative
No.
1.
Go ahead.
Negative 1/3.
Perfect. And why? What did you do, Kelly, to get that?
I plugged in -3 for.
All she did is she just said, hey, instead of this x, she put a -3 in there. I hope everyone can do that. So maybe this next one I'll get more answers. What's -2? What do you get when you plug in a -2?
-1/2.
Perfect. Thank you. What happens if I put a -1 in? What do I get out for an answer? Forrest, what do I get, buddy?
You get -1.
Perfect. Careful on this one. What happens if I put a 0 in?
You just
Undefined.
Is it 1?
Okay, so I got is undefined as an answer. I have 1 as an answer. Did anyone else have an answer?
I just
Wouldn't it just be 0?
0.
Okay, 0 is a common answer.
0.
One of these is correct. So let's think about division. If I say 2 divided by 2, that really means I have two things. We'll just represent them as dots. And what happens is they want me to make groups of 2. So I go, okay, this is group 1, this is group 2, and I say, okay, dot, you go here, and you go here. And so what happens is you're going, okay, now how many is in each group? And your answer is 1, right? If I have two things, I make two groups, one thing is in each group. That's what division really is. You got to understand concepts like that because they help us with these bigger things, this bigger idea. So like if you had 4 divided by 2, right? That means you have 4 things. We'll draw sticks this time. We have 4 sticks. We have group 1 and group 2. And you go, okay, you go to group 1, you go to group 2. You go to group 1, you go to group 2. That's what we did, and we're dividing them up evenly. And if you look at it, how many is in each group? 2 things, right? Just like if you even did something kind of weird. What if you took, and we're trying to use small numbers to make this, so the concept, 3 divided by 2, that means you have 3 things, and you're making groups of 2, and you're going, okay, you go here, you go here, and you're going, wait, this guy, sorry, we're going to have to split you in half. So this guy gets 1 full stick and then a half stick, and then this guy gets 1 full stick and a half stick, and so the answer is 1.5, right? That's 3 divided by 2. What am I asking you to do in this next question? In this question, I'm asking you to take one thing and make groups of 0. That means you have to use this stick and make 0 groups. You're going, what? That's not possible. Exactly. That's why the answer is called undefined. It is undefined. We don't really know what happens there. You can't do it. It's not possible. Now, the only time that that is not true, it doesn't matter if it's 5 over 0, it's undefined. If it's negative 1,000 over 0, it's undefined. The only time that that is not undefined is when you have 0 over to 0. and that is called an indiscriminate form. In fact, people are still studying this form today. There's 6 of them that they still are kind of looking at and trying to understand more. And what I'm telling you today is, I think that if we discover things more about like what 0 over 0 really means, we're going to unlock something really cool. I don't know if that's time travel. I don't know what it is, but I know that anytime something is unlocked in math, some kind of new invention, something that we didn't think was possible, all of a sudden becomes possible. We were talking about in class today that some kid was like, yeah, Mr. Martin, remember how they in movies, I was saying that sci-fi, a lot of times the things that are in sci-fi movies actually come true later on, years down the road. There was an old show that was called Knight Rider. It was about a car, and this car, I'm going to attempt to draw cards. It's pretty terrible. Shut up. Especially Knight Rider. That is not what Knight Rider looks like. But Knight Rider was a car, and this guy, he would be standing over here. His name was David Hasselhoff. He had a watch, and he would say, Knight Rider, come pick me up. And Knight Rider would zoom over with nobody in the car and would come over to him. It was the first like kind of like computer, fully automated car that would basically drive itself, and the guy talked to it using his watch. If you don't think we're close to that today, you're out of your darn minds. I mean, we are getting closer and closer to cars being able to drive themselves. We have watches that can communicate and send text messages. We tell them, hey, Siri. Oh, sorry for anyone's phone who just went off. But we tell them all kinds of things, and they do things for us. We are close to that. That is all happening through math and science working together and understanding forms like this that we don't know. So math is still being discovered today. And this is one of the forms that it's not undefined. It is called an indiscriminate form. Kind of just means we need to study it a little bit more. And that's what people are still doing today. So sorry about that little side note, but just wanted you to know anything divided by 0 is undefined except for 0 over 0. We could continue on if we put a 1 in here. That would mean 1 over 1, which is 1. We could continue with 2. 1 over 2 would be a half, and then 3. 1 over 3 would be a third, and we're going to start this graph. We're going to get better today. We'll see what happens. I don't know how far we're going to get. But let's see what happens. Right here, this is called undefined. This is that new word called an asymptote. It's called an asymptote. Asymptote, okay? That is an asymptote. That means that on this graph, there will be a dashed line at x equaling 0, and it means the graph will never, ever, ever touch or cross that line. Vertical asymptotes are very definitive. That means the graph will never, ever cross that. That will never happen. They are very, very definitive. They're final. They do not get crossed. There's also actually another asymptote, and I'm going to show you where it appears and why. We're not going to talk too much about these yet. We're going to get into much more detail later on. But there is a horizontal asymptote actually at y not being able to be 0. And y cannot be 0. Now here's the reason y cannot be 0. Someone give me a fraction that is 0. I want a fraction that equals 0. Destiny, I haven't talked to you all day today. Destiny, give me a fraction that equals 0. Hello, Destiny. Goodbye, Destiny. Sierra, try again. You there, Sierra? All right, you can't use your mic. It's really helpful if you can use your mic. Isabella. Can you give me a fraction that equals 0?
Yeah.
What would be a fraction that's 0? Can you give me an example of one?
Yeah. Would it be a number over 0? Like, or
No,
0?
because we said anytime you're dividing by 0, that can't happen. So where would the 0 have to be in order for it to be the fraction to be 0?
I'm not sure. So.
Okay. It's all right. I appreciate you trying.
Yeah.
Boris, can you give me an example of a fraction that's 0?
Zero over 7.
Perfect. Because we said this is how many things we have, and we're making groups of 7, right? If I have nothing, how many is in each group? Well, I have 7 groups. 1, 2, 3, 4, 5, 6, 7. And there's nothing to give them, so how much is in each group? 0, right? That's the answer to a division problem. So what has to happen in order to have a fraction where I'm getting 0 as the final answer? The numerator has to be 0. The top number has to be 0. What do we know about this equation? Kelly, what do we know about the numerator?
It can't be 0.
Yeah, or else it can't be 0. So what does that mean? This y will never ever be? It'll never ever be 0. Why? Because this will always be something. Think about it. If I put in numbers for x, even if I put in 1,000,000, what is 1 over 1,000,000? It's a small number, but it's not 0. It's something, because there's always 1. Even if I put a negative, like 1 over negative 1,000,000, right? It's still something. It's very small, but it's still something. It's still 1. The only way this could be 0, where we would never have anything coming out, would be if the top number could be 0, and we know it can't be, because for this equation, it's going to be a 1 every single time. So that's where that horizontal asymptote is coming from, if that makes sense, that this will never ever be 0. So we drew that in. And then if we draw these orders pairs that I gave you, the first one was -3. You should have that written down. And it was -1/3, and that's like right in here. And the next one was -2, -1/2, which is about there. And the last one was -1, -1. And what's going to happen with the graph is graphs always chase the asymptote. So you're going to hear me chasing that asymptote. You're going to hear me refer to that, because that's what these graphs are always going to do. It's going to chase this horizontal asymptote, and then as it approaches this one, it's going to chase the vertical asymptote, the blue one that I need to extend. It's going to keep going. This graph right here will get infinitely closer and closer and closer to this line. As close as you can get, closer than my pen can even write, closer than a pencil, the sharpest pencil could write. It's going to get closer than that. It will keep approaching that line, but will never ever touch, nor will it cross it. In fact, you'll notice when we have vertical asymptotes, the graph on the other side changes shapes kind of sometimes completely. But if you look at this, the next one was, if you put a 1 in, you get a 1 out. If you put a 2 in, you get a half out. If you put a 3 in, you get a 1/3 out. And again, this idea of chasing the asymptote is going to keep happening here, and it's going to keep happening up here. And finally, I want to talk about, like, how does this part of the graph make sense? Well, if this is the number 1, does that make sense that this would be a half? Well, if I put in half for x, that would end up being have 1 over 1/2, which is equivalent to 1 divided by half. We've talked about this earlier. I can flip that, which means I end up with 1 times 2 over 1, or just 2, which means if I put a 1/2 in for x, I kick out a 2, which if I put a 1/2 in, I kick out a 2. That makes sense. Just like if I put a 1/3 in, it kicks out a 3. And if I put a 1/10 in, it kicks out a 1/10. Because this thing is just so that y is going to keep getting bigger. If I put in a 1,000,000th, my output is 1,000,000. Right? So this thing is going to get closer and closer to this asymptote without ever touching it. Now, the last thing that we're going to talk about today, and then tomorrow we'll do this some more, we're going to cover the graphing a ton, is if I had y equals 1 over x minus 3. This is the last thing I really need you to get for today's lesson. This is like in parentheses, except it will never be written. You're gonna see it more like this. You need to understand this as parentheses, because just like we did last time, this is going to move things the opposite way, right and left. This is going to move things up and down. So just like everything, our asymptotes that are normally at y equals 0 and x equals 0, they're going to be affected by this movement left and right, and this one's going to be affected by it up and down. Well, if I move this one left and right, it's going left and right infinitely, so it's not going to be affected left and right, but it will be affected by moving it up 2. So this asymptote that was here is now actually going to be up here. So this right here moves the vertical or the horizontal asymptote up 2. This right here, which moves things to the right 3, is actually going to move this asymptote that's up and down to the right 3. So my vertical asymptote is actually going to be at x equaling 3, and my horizontal asymptote is actually going to be at y equals positive 2. This is huge. You should be able to get this by the end of today's class. You should be able to identify and label the intercepts or the asymptotes. So if I said y equals 1 over x minus 4 plus 7, my vertical asymptote should be this moves it to the right 4. So instead of, it's going to be x equals 4. And this right here is going to move the horizontal asymptote up, which is going to make it y equals 7. So that would look like this on a graph. 1, 2, 3, 4, 5, 6, 7. There would be an asymptote here. 1, 2, 3, 4. There would be an asymptote right here. Sometimes just by knowing the asymptotes, you can identify which graph of a multiple choice answer is the correct one. Y equals, that doesn't matter, 2 over x minus 3 minus 2. What's my vertical asymptote? Nina, what would be my vertical asymptote?
Would it be 3?
What is 3? It's not just 3.
The vertical asymptote.
But it's an equation, so it needs a variable with it. The variable for vertical asymptotes is
Oh,
x.
x equals 3.
Perfect. And then what would be my horizontal asymptote?
Y equals 2.
Careful.
Y equals negative 2.
Remember, this is the opposite. The one on the outside is the one that it is. Remember, this is in parentheses, so this is the opposite. This moves it the opposite way, I think. This moves it the way I think.
Oh, right. Okay.
So that's why this was a 3, the opposite of it. That's why this one was a negative 2. That's it. That's what I need to know. Y equals 1 over x minus 7 plus 6. Tucker, what's my vertical asymptote?
Sorry, I don't know.
Hey, Tucker?
Yeah.
That's not going to work on this one, buddy. You're going to stick with me. So stay unmuted because we're going to talk, because by the end of this, you should know how to do this.
All right.
The vertical asymptotes come from the denominator becoming 0. That's why they were made. Okay? So what number would make this bottom 0?
A positive 7.
So your vertical asymptote is called x equals, and what number did you just say?
7.
Thank you. Your horizontal asymptote comes from right here, and it is that number. It is just y equals 6. So I'm going to give you another one. Stay unmuted. What is your vertical asymptote? Where does it come from, Tucker?
5. So it's negative 5.
So what is that? I never just put 5, or I never just put negative 5. What did I put in front of that?
X.
X equals negative 5, because that's the line. X equals negative 5. is this line right here. And that's the equation for it. That's the vertical asymptote. What's my horizontal asymptote?
3.
Two things wrong. First off, I need a variable.
Y equals 3.
And it's this exact
Negative
thing.
3.
That's how you find the vertical and horizontal asymptotes. Now,
All right.
why is the vertical asymptote happening? Because you cannot have the denominator 0. This is the number that would be 0. That's why x can't be that number. That's why it says x can't be that number. Why? Because if you put a -5 in here, this turns to 0, which we can't divide by 0. If you even put it in a calculator, if you put 1 divided by 0, the calculator is going to say error because it can't do it. So that's why x can't be -5. How come y can't be -3? Well, because this is going to be some number. It might be a very, very small number, but this is going to be something. And if I take -3 and I add even the smallest number, it's not going to be -3. If I take -3 and I subtract, or this is like a negative number, it's still not going to be -3. This number right here will never be what number?
0.
And so that's the only way this could be -3. Why would be -3 is if this right here all turned to 0, then you would have 0 minus 3, which would be -3. But we know this will always be something -3, which means this y can never be -3. Is that kind of making sense?
Yeah.
If I'm talking, Tucker, and you do not understand something, you've got to stop me. This is not a play around class. This is not baby school. You've got to stop me because this is going to be what you're going to build off of from now on. SATs, ACTs, entrance exams, everything. You've got to start taking this as like an adult. We've got to be a lot more serious with our education and saying, I don't get it, Mr. Martin, I need help. That's enough for today. Tomorrow we'll actually go over graphing these a little bit more details, not just with the asymptotes. We'll actually make the graphs and continue on from there. All right. Other than that, you guys can go ahead and go. We're good for today.